Lesson 8-2 is the last review lesson we're going to do about lines and functions and equations before we start this next chapter on statistics. This is representations of a line. It talks about the rate of change in initial value given the context of the problem. So it says that a truck rental company charges a $150 rental fee in addition to charging 50 cents per mile driven. In this problem, you'll graph the linear function relating the total cost of the rental in dollars to the number of miles on the axis below. So question A says, if the truck is driven 0 miles, what will be the cost to the customer? If they don't drive any miles, they still have to pay the rental fee. In this case, the rental fee is $150. How will this be shown in the graph? This is called the y-axis, or the y-intercept, sorry. This is where it intersects the y-axis. And the ordered pair of this is 0, 150. So I'm going to put that in the graph up here. 0, 150. So this is the cost even if they don't drive anywhere. What is the rate of change that relates the cost to the number of miles driven, which is also called the slope? And this is 50 cents per mile. Explain what it means within the context of the problem. Every mile driven is equal to 50 cents. We'll put more there too. On the axis given, sketch the graph of the linear function that relates C to M. So I have the first point, that's the y-intercept. I need another point somewhere over here to connect them. It'd be easiest to go up by 100 miles. So I have to pay the $150 no matter what. And if I drive 100 miles, I would take 50 cents and multiply by 100 miles, which is $50. So the total cost for 100 miles would be $200. So 100 miles, $200. And for every 100 more miles, it's $50 more. So for 200 miles, that would be $250. And you notice a pattern here. If we go from the previous point up 1 over 2, up 1 over 2, if I go up 1 over 2, and I keep doing that, that will give me my line. And I'm going to graph this. So it's going to look something like this. So this is the graph. Write the equation of the linear function that models the relationship. So I want it to be in y equals mx plus b form. I know my slope, that's 50 cents. And my y-intercept is 150. So this would be my function in slope-intercept form. On the next page, Jenna bought a used car for $18,000. She has been told that the value of the car is likely to go down $2,500 for each year she owns a car. Let the value of the car in dollars be V. The number of years she owned the car be T. So question 9, what is the value of the car when T equals 0? Meaning when she just buys it, what is the value of the car? That's $18,000. Show this point on the graph. Well, that's the y-intercept, so it's 0, 18,000, which is right here. What is the rate of change that relates V to T? Hint, is it positive or negative? In this case, it's negative because it tells us it decreases. So it's negative 2,500. How can you tell? Because it decreases, goes down. Find the value of the car when T is 1. So it would go down $2,500 for 1 year. So 18,000 minus 2,500 times 1 year. That's $15,500. I would do the same thing for t equals 2, 18,000 minus 2,500 per year for 2 years. So 2,500 times 2, that's 5,000. So that means my car is now worth 13,000. And for 7 years, 7 times 2,500 is 17,500, so I get $500 left. So after 7 years, my car is almost worth nothing. Plot the points for the values you found in exercise 11. Draw the line using a straight edge, passes through these points. So I'm going to plot these points. This one is 1, 15,500, 2, 13,000, and 7, 500. So 1 and 15,500, 2, 13,000, and 7, 500. And if I connect this graph, you're going to notice that it's a decreasing function. So over time, it decreases. So for 13, when I write this linear function, I know it's got to be a decreasing function because the slope is negative. So I'm going to, again, write it in y equals mx plus b form. And I know the slope this time is negative 2,500. And my original cost of the car was 18,000. So this time would be my linear function. Remember, the slope can be negative. That just means that it's going down. And the last question, an online bookseller has a new book in print. The company estimates that if the book is priced at $15, then 800 copies will be sold. If they sell it for $20, then they're going to sell 550 copies. Identify the ordered pairs given in the problem, then plot the graph. So up in the problem, it tells you the price is X. So if I sell the book for $15, I'm going to end up selling 800 copies. So that's an ordered pair. And likewise, if I sell it for $20, they can sell 550 copies. So there's my two ordered pairs. Assume the relationship between the books is linear. So we're going to plot the graph 15, 800, and 20 would be 550. And we're going to connect that. And I'm going to make this longer all the way to the y-axis. What is the rate of change relating the number of copies sold to the price? This would be hard to use the graph, so what I'm going to use, they're asking to find the slope, which is the change in y over the change in x. So I'm going to use the 2 points that they gave me. 800 minus 550. So I'm subtracting the y values over the x values, 15 minus 20. So I get 250 over negative 5, which tells me that this whole fraction is negative, which is negative 50 is my slope or rate of change. Based on the graph of the company prices the book at $18. So if I go up here and I find $18 and I go up, it meets at 650 copies. Based on the graph, approximately what price should the company charge in order to sell 700 copies of the book per day? 700 copies, so they want to know approximately. Here's 700 copies. I go over. It intersects right here, so I go down, and it would be $17 for 700 copies. So the more expensive the book is, the less they're going to sell of them. So a few things just to keep in mind. We already talked about rate of change is the slope, and the initial value is y-intercept. We can sketch the graph. We talked about that. All we need is two ordered pairs to write the linear relationship. So we can make a graph with two pairs. We can come up with the equation with two pairs. These are all things that we're going to use starting tomorrow as we go through this chapter.